Welcome back to the Geology Dean's Masterclass on Sedimentary Rocks. In today's episode, number 11, we journey into the vast and dynamic world of sedimentary basins. These are not just any depressions on the Earth's surface. They are the grand theaters where the story of our planet is written, layer by layer, over millions of years. But how do these massive containers for sediment actually form? The primary driver is a process called tectonic subsidence, where the Earth's crust sinks or settles. Imagine it as the ground floor slowly lowering, creating more and more space for sediments to accumulate above. This subsidence is the key to forming the thick sedimentary sequences we study today. It's what allows for thousands of meters of rock to pile up in one location. There are several major types of sedimentary basins, each telling a unique tectonic story. Let's start with rift basins. These form where the Earth's crust is being stretched and pulled apart. As the crust thins, blocks of it drop down, creating long, narrow valleys. Think of the East African Rift Valley. It's a modern example of a rift basin in the making, trapping sediments from surrounding highlands. Over geologic time, these rifts can fill with incredible thicknesses of sediment and even volcanic rock. Eventually, a rift might evolve into a new ocean basin. Next, we have foreland basins. These develop adjacent to mountain ranges. As one tectonic plate pushes over another, the immense weight of the overriding plate and the newly formed mountains causes the crust in front of it to flex downwards, like placing a heavy book on a soft mattress. This creates a trough, the foreland basin, that eagerly collects the erosional debris, the sand, silt, and gravel, shed from the rising mountains. The Himalayas, for example, have created the massive Ganges Basin in front of them, a classic foreland basin filled with sediment eroded from the world's highest peaks. Finally, let's look at passive margins. These are not tectonically active boundaries. They represent the transition between continental crust and oceanic crust, formed after a continent has successfully rifted apart and an ocean has opened. The coastline of the eastern United States is a perfect example of a passive margin. Here, subsidence is slower and driven by the cooling and sinking of the crust as it moves away from the old rift zone. This gradual sinking creates a broad, wedge-shaped accumulation of sediments that thickens towards the ocean. So, why is understanding these basin types so critical? Because each one provides a distinct fingerprint of the tectonic forces at play. By analyzing the geometry of the sediment fill, the types of rocks present, and their internal structures, we can reconstruct the tectonic history of a region with remarkable accuracy. Furthermore,